So now we're doing exercise 1F, question 13. And the question says, let A be a positive number, and there's a function f, which goes from 2 to infinity to r. We're not quite sure what the range is. We're going to have to find out. And the rule is a minus x. And we've also got a function g, which has the domain from minus infinity to 1. And the rule is x squared plus a. And we want to know that f of g and g of f both exist. So what we're going to have to do is do our little table of the domain and range of both of these functions. So the domain of f, we're told, is 2, infinity. What's the range of f? It's a minus x. So when x is 2, it's going to be a minus 2. And when x is infinity, it's going to be a minus infinity, which of course is minus infinity. So the range is going to look like that. Now we come to g. The domain is minus infinity to 1. And the range, well, it's x squared plus a. So it can be any number plus a, any non-negative number, because minus infinity squared is going to be plus infinity. 1 squared is going to be 1. But between minus infinity and 1 is 0, which in 0 squared is 0. So basically, x squared, if it comes from the range of g, from this range here, if you square any number between here, you're going to get anywhere between 0 and infinity. If you add a, you're going to get anywhere from a to infinity. So that's what the range is going to look like. Now we want f of g to exist and g of f to exist. If f of g exists, that means the range of g must be inside the domain of f. So we need that a to infinity is inside, could be the same as, but it can't be any bigger than, 2 to infinity. So the only way that a to infinity can be inside 2 to infinity is if a is greater than or equal to 2. That will mean that this set will be wholly inside this set, or a could be equal to, in which case this set is the same as this set. So we're saying that a must be greater than or equal to 2. We also have to consider that g of f exists. Now, in which case we want the range of f to be inside the domain of g. So that means in minus infinity to a minus 2, sorry, it's very hard to write on this, is inside minus infinity to 1. And the only way that can happen is if minus 2 is less than or equal to 1. Sorry, a minus 2. There's a mistake there. A minus 2 is less than or equal to 1. A is less than or equal to 3. And so the final answer is that a has to be less than or equal to 3, but greater than or equal to 2. And that's the answer. I think I might need to go over this last point here, how I got from there to there. Well, consider what we have here is two sections of the number line. This section of the number line goes from minus infinity to a minus 2. And this section of the number line goes from minus infinity all the way to 1. We want this section of a number line to be included in this section of a number line. So they both start at the same point on the far left at minus infinity. So this point a minus 2 must be less than the point here of 1. If it were a minus 2 were bigger than 1, then this line would actually exceed this line as a section of a number line. This set will be bigger than this set. The only way for this set to be smaller, to be included in this set, or the same as this set, is if a minus 2 is the same as 1 or less than 1, which is what we've said here. So the final answer is a is between 2 and 3.